All right, now we're ready to talk about the operation of a matrix inverse. Now, first, before we talk about a matrix inverse, let's just talk about the inverse of a regular scalar. So if I have a scalar x and I take its inverse, if I take x and I multiply by its inverse, then I get 1, and that's actually how inverse is defined. Also, we'll note that with a scalar, x inverse equals 1 over x, right? And so that's just another way of writing x inverse. With matrices, it's actually the same way. We have a matrix A, and we define its inverse as the matrix by which A is multiplied, A inverse, to get not 1, but the matrix equivalent of 1, the identity matrix, the diagonal matrix with entries of 1 along the diagonal. So that is the matrix inverse. There are the terms left inverse and right inverse. This is a right inverse. The left inverse would be a inverse A, and it can be shown, I won't bother going through it here, that if a left inverse exists for a square matrix, then the right inverse also exists, and if they both exist, then, or if either one exists, both exist, and if both exist, then they're the same. And so it's not important to distinguish whether you're doing left multiplication or right multiplication when we're dealing with the inverse. Well, I mean, it can be important, but the inverse, this term itself, is the same. What I'm saying is, it doesn't. The left inverse and the right inverse are equal, and so you don't need to distinguish between the two.